In today's video, we're actually going to find molar mass of some different compounds. In order to find the molar mass of any compound that we're going to solve for, we're going to need a chemical formula. So you're going to need to know your nomenclature. Once you have your formula written, all that we do is we look up the mass, which is the number on the bottom on the periodic table, and we add however many there are to get overall your molar mass. When we're writing our molar mass, that's the mass of 1 mole. So we're going to have 1 mole is equal to whatever mass in grams. And we're going to write it like this because it's a conversion factor. We're going to need those conversion factors as we go through our dimensional analysis on the mole and on stoics. We're just going to get in the habit of writing it like this. So the first one that I have here is just calcium. Calcium is a single element from the periodic table. Its formula is just Ca. So when I find calcium on the periodic table, it says its mass is 40.08. We usually round to 2 decimal places for sig fig reasons on your molar masses. So we're just going to write down that 1 mole of calcium is equal to 40.08 grams. Now this next one here we have fluorine. For your fluorine, it's an F, but it's part of Brinkelhoff, or it's diatomic, so that means that it gets a 2 after it. So I have 2 fluorines total. So what I need to do on that one is I'm going to look up the mass on the periodic table, which is 19, but that's the mass of 1 of the fluorines, but we actually have 2. So if you don't know 19 times 2, we take 19 times 2. 1 mole of fluorine has a molar mass of 38 grams. Again, I'm writing it with 2 decimal places for the sake of sig figs because we're going to need those later. Now the next one says sodium phosphide. Sodium is Na, has a +1 charge. Phosphide is phosphorus, it has a -3. So we end up with Na3P. So we're going to do the same thing that we did before. We need to find the mass of sodium on the periodic table, which is 22.99. Find the mass of phosphorus on the periodic table, which is 30.97. So we're going to add the mass of our 3 sodiums plus our 1 phosphorus. So 22.99 times 3 plus 30.97. 1 mole of your sodium phosphide has a mass of 99.94 grams. On the last one that I have down here, we have barium carbonate. Barium Ca, it has a +2 charge. Carbonate is CO3 -2. So when we swap and drop there, it's just BaCO3. With this one, we're going to find the mass of barium on the periodic table, which is 137.33. The mass of carbon on your periodic table is 12.01. And each oxygen has a mass of 16. So when we solve for this, we have 3 oxygens, so 16 times 3, plus 12.01, plus 137.33. 1 mole of barium carbonate has a mass of 197.34 grams. I'm going to add one real quick that I didn't write down before that has parentheses in it. So how about we have magnesium chloride. Not chloride. How about chlorate? Magnesium chlorate. Sorry. So if we have magnesium chlorate, that one, magnesium has a +2 charge. Chlorate is ClO3 -1. So we end up with MgClO3 2. Now with this polyatomic ion here, you're going to have to actually solve for each mass of chlorine, each mass of oxygen. So we have 2 chlorines and we have 6 oxygen. The mass of magnesium, when you look it up on the periodic table, is 24.30. Mass of chlorine on the periodic table, 35.45. The mass of oxygen on the periodic table is 16. So we're going to take, and it's easiest just to plug this all in the calculator at the same time, 24.30. Plus, I have 2 of the chlorines. So 2 times 35.45. Oops, 35.45. Close up my parentheses. We're going to add that to our 6 oxygen, so 6 times 16. So our molar mass on magnesium chlorate, 1 mole of magnesium chlorate has a mass of 191.20 grams. Again, I'm writing it with 2 decimal places because I'm going to need those decimal places later on down the road with the math.